Hello everyone, welcome to your physics class of class 7th. I hope you all will be fine. Students, in our previous video we had started lesson number 6. Now today in this video we will continue the lesson. So let's begin our class. In our previous video we studied about sound, what is sound, and sound is produced due to vibration, this we studied, and the different sources of sound, that is tuning fork, musical instruments, human beings, these are the different sources of sound. Now today in this video we will study that sound needs a medium for propagation, means for sound to reach from one place to another it requires a medium for its propagation. Okay, sound cannot travel through a vacuum. Vacuum is a place where there is no air, so we cannot hear sound at a place where there is a vacuum. Sound requires a medium for its propagation, that is from traveling from one point to another. Means sound to be heard from one point to another, it needs a medium for its propagation. Okay, so we will see this experiment. Take an electric bell and an airtight glass jar connected to a vacuum pump. You can see here this is an electric bell which is connected to a battery, and this is the bell jar, and a vacuum pump is connected to this bell jar. Now suspend the electric bell inside the jar as shown in this figure. Now connect the bell to a battery. This bell is connected to a battery here. Now pressing the switch, you can see here the switch. On pressing the switch, the bell starts ringing and the sound is heard. Means as soon as we switch on, this bell will start ringing and we can hear the sound of this bell. The sound reaches us through the air that is present inside this jar. Now, as soon as we start this vacuum pump, it will withdraw all the air from the jar, and you will notice that as the jar is evacuated, means as the air is pumped out with the help of this vacuum pump, you will hear a feeble sound, and after some time when there is no air within the this bell jar, no sound is heard. However, the hammer of the electric bell can be still seen striking. This is a hammer of the bell because of which we are able to hear the sound of the bell, and we can clearly see this is a transparent bell jar, that this hammer is striking the this bell, but we are not able to hear the sound. Why we are not able to hear the sound? Because now there is no air left in the jar and the sound does not reach us, although the bell is still ringing. Understood now? So from this we conclude that sound cannot travel through a vacuum. On moon and in space there is no atmosphere, therefore two persons cannot hear each other. Means on moon and in the space there is no atmosphere, as there is no medium, two person cannot hear each other. Okay, now this is an activity. Now this activity is to prove that sound needs a medium for its propagation. Take a tumbler and place a mobile phone A inside the tumbler, and now ring the mobile phone A from another mobile that is outside the tumbler. This is mobile B and this is mobile A inside the tumbler. Now when we will call from this mobile B on mobile A, we will hear the sound of this mobile phone outside the tumbler, because there is air in the tumbler through which the ring propagates to reach your ear. Means because of the air that is present in this tumbler, we are able to hear the sound of this ringing of this phone. Now cover the mouth of the tumbler with a cardboard lid having a small hole, as you can see here in this picture. Now cover this tumbler with the cardboard with a lid through which we can pass a straw. You can see here this is straw, and by creating a hole in this cardboard, we pass this straw into the tumbler. Now again when we will ring from mobile B to on mobile A, from mobile B, you will find that the sound of the ring gradually decreases as we withdraw the air that is inside the tumbler, and ultimately when almost all the air is sucked out from this tumbler, no sound is heard. This also shows that sound needs a medium for its propagation. Means when all the air is withdrawn from this tumbler by sucking from this straw, you will not be able to hear the ringing of this mobile phone A. Okay, so this also shows that Sound needs a medium for its propagation, means to travel from one place to another. Okay. Now, sound also can travel from not only through air but also solids and liquids. Okay. Now, sound travels in air in the form of longitudinal waves. We have studied that sound is a form of energy and it only vibrates. It is only produced when a body vibrates, means sound is produced when a body vibrates. This we have already studied. Now, during vibrations, the kinetic energy changes into potential energy and potential energy changes into kinetic energy. The sound energy in air is transmitted from one place to another by wave motion, means the sound energy in air is transmitted from one place to another, means it propagates in the form of wave motion. Now, in wave motion, the particles of the medium, means this is a body that is vibrating, so the particles of the medium surrounding it do not leave their position. They only vibrate on their mean position. Okay, so like this, in this way, wave motion is produced. And when a body vibrates, the particles of air surrounding it is vibrating about their mean position, means the body, when a body vibrates, the particles of air surrounding that body also starts vibrating about their mean position, and during vibration they push or pull the nearby particles and transfer their energy to the next particle, means that is surrounding that particular particle. So the air particles starts vibrating and they push the nearby particles and transfer their energy to them, and then they start vibrating faster and transferring energy to the next surrounding. The same way this particular particles start vibrating on their mean position, and the same way they will transfer to the next particle surrounding them. Now, this process continues till the vibrations reach the ear of a person. Okay, so as you can see here in this figure number 6.18, these are the air particles that are vibrating and passing their energy to the nearby particles. Such vibrations of particles in air are in the direction of propagation of sound, and the vibrations of particles is in the direction of propagation of sound, means in which direction the sound is traveling. Okay, and they form longitudinal waves. In longitudinal wave, as you can see here at point C, on either side of which the particles move towards the point C. Here you can see this section is known as compression. Okay, and the point at you can see here R, on either side of which the particles move away from the point R, this is known as rarefaction. So this is compression and this is rarefaction, and these arrows shows the direction of movement of the air particles. So when the air particles move towards a particular point, that is the compression part, and this is the rarefaction part. Okay, and one wave is from a compression to next compression, means one wave is complete from one compression to the next compression, or from a rarefaction to another rarefaction, next rarefaction. As you can see here in this diagram, this is one complete wave, means from one compression this to from this to this rarefaction to rarefaction, and from compression to one compress. This is compression. So this is one complete wave. Okay. A longitudinal wave is graphically represented by the displacement distance graph, as you can see here. This graph shows the displacement of particles of medium at different distances at the same time. Okay, so this is the rarefaction. These are the rarefaction points, and this is the compression point. So one wave is completed either from rarefaction to rarefaction or from compression to compression. Now, another way to represent a longitudinal wave is displacement time graph, which represent the displacement of particles of the medium with time at a given position. This was the displacement distance graph, and now this is the displacement time graph. We can also represent longitudinal wave in this displacement time graph. Okay, and this shows the displacement time graph in which the time of one wave is represented by the letter T. This is one complete wave from rarefaction to rarefaction to the next rarefaction, and this is the time taken by one complete wave. Okay. Now you can see this box. Do you know? First one is the distance traveled in one direction is called displacement, means the distance when traveled only in one direction, that is known as displacement. Second is, in a longitudinal wave, the distance moved towards right is on positive y-axis and the distance moved towards left is on the negative y-axis. All of you know what is x-axis and y-axis. So this direction towards right is on positive y-axis and distance moved towards left is on the negative y-axis. Now third one is frequency of a wave, means the formula for frequency in terms of time period is frequency equals to 1 upon time period, and speed of wave is equals to frequency multiplied by wavelength. Okay. Now fifth one is in displacement distance graph, if there are more waves in a same distance, wavelength is less, so frequency is more. Means as you can see here in this figure, if there are more waves in the same distance, so the wavelength, that is the distance between a wave. Okay, so this is less, that is wavelength is less for one vibration, so wavelength will be less and its frequency will be more. So its frequency is more. Now in the displacement time graph, if there are more waves in same time period is less, so its frequency is more because frequency is reciprocal to time period. Okay, so this is all for today. Now what you have to do, you have to read this lesson up to here, and further explanation we will continue in our next video. Okay, thank you.